So on that note, the next thing that we are going to be doing is integrating Ethereum Interoperability Layer into Ambire. And that is going to be with Ivo Georgiev. All right, you can come right up. Thank you.
Hey, everyone. You guys can hear me, so that's a good sign. So just waiting for the slides. First of all, I'm Ivo. I'm a co-founder of Ambire and CEO. And first of all, let's start with what is Ambire mission. So what we want to do is we want to make self-custody more accessible to everyone. And in order to do this, we essentially need to make it easier, more secure, and also more private. So what is EIL's mission? So essentially, EIL's mission is to make Ethereum feel like one chain, which is something that tons of projects do and tons of projects promise. But the big difference with EIL is that the whole goal is to do this without compromising on the crops values. So essentially without compromising censorship resistance, open source, privacy, and security, which is also something that Ambire is really aligned with. So problem statement. So why do we need to solve this problem in the first place? Why do we need to make Ethereum feel like one chain? We all know about this. We've all seen this. Having like 5 USDCs and having like 3 or 4 Ethers. And this problem is even made worse when you consider that most layer 2s require some kind of a native token. And in order to have gas, in order to use this layer 2, you need to have Ethers on multiple networks. So that's really fragmented. And yeah, that's also another problem that Ambire solves, but EIL solves as well. So first of all, the thing is, why don't we simply consolidate this? We have been asked about this for maybe 2 or 3 years, ever since pretty much Ambire was launched. Why don't we just sum all of the USDCs, sum all of the Ethers, and show them in one entry? So the issue with this is that this is a leaky abstraction. And what is a leaky abstraction? A leaky abstraction is something that you try to hide some complexity, but then it kind of wields its ugly head a little bit later in the user flow. So one example of this is you go to a dApp that only supports a subset of those networks, and you only see a subset of your balance, or you even see a balance that you don't even recognize. So you could have a total of 100 USDC, but in a certain dApp you're going to see 10, which is scary. And then another example of a leaky abstraction here is imagine that the user flow is very simple for 10 USDC, but when you add only 1, the user flow becomes completely different because you have 10 on the chain that you want to do something, but when you want 11 on that chain, it has to pull this 1 from a different chain. So 1 USDC could be the difference between only 1 transaction signature or having not only to sign multiple transactions, but to wait for a bridge, which is, in my opinion, pretty horrifying. So how does the Ethereum Interoperability Layer help us solve this? So essentially, the core thing that we use from the Ethereum Interoperability Layer at the moment is the multi-chain execution. So essentially, the ability to sign operations on multiple networks in only one signature. So I'm sure that all of you will be asking this question not only once but many times today. How is this different from the open intent framework, or how is this different from the intent model in general? And the way to explain this is not short, but basically they cover completely different bases. They're completely different concepts. And transactions describe very exactly what you need to do, and intents describe very abstractly what the user wants to do. But they're not competing with each other in a sense that you need both of those concepts. So in a practical example, in a wallet like Ambire, the user would need to, let's say you want to use a balance from 2 different chains, and you want to go on a 3rd chain and buy some NFT. In that example, you can still use intents. Like the wallet can broadcast to an intent network. It can say, please give me the most optimal solution. And then solvers would compete for the optimal solution, and they would relay this solution back to the wallet. But then the execution is something that the Ethereum Interoperability Layer actually helps us with. So you can think of it as an execution engine that can be used either with intents or without intents. So in many ways, it can replace intents for simple use cases because it also includes a primitive for moving assets across chains. So in some ways, it can replace intents altogether. But as I said, they're generally completely different things. And you can think of the Ethereum Interoperability Layer as an execution engine for those intents. So another way to explain it, in a classic intent system, you have an intent execution engine and you need to give approvals for this intent execution engine smart contract for it to work, which is still a very big user hassle. And with EIL, you will be able to just one signature and execute whatever you want to execute. So what is it useful for right now from Ambire's perspective? So from a wallet perspective, what is Ethereum Interoperability Layer useful for right now? So first of all, one of our main holy grails of chain abstraction, right, which is balance consolidation, making everything feel like one chain, consolidating balances, and doing it without leaky abstractions. So doing it without introducing complexity later down the flow. And then the second thing that is really cool for is fixing user experience for multi-step bridging. So what this is right now we use third-party providers like Socket and LeFi to do bridges. Later on, we can replace that with the open intent framework or with some other more open decentralized solution. But my point here is that those solutions, they provide two modes of operation in that sense, which is single step and multi-step. And in the single step flow, the user only has to sign one transaction. In the multi-step flow, the user has to sign one transaction, wait for the bridge, and then sign a second transaction, or maybe even third. So the problem with this is that it's incredibly incompatible with the modern user. The modern user doesn't have the attention span, and I don't blame people, obviously. I also want everything to be done immediately. And more importantly, when a user, we have conditioned users that when you've signed the transaction, that your work is done. From that point on, you're simply going to wait for something to be accomplished, for something to happen. So with the EIL, we can ask the user only for one signature and authorize a chain of actions. So not only like multiple transactions that are going to happen, that are going to get executed at once. No, we're executing a chain of actions where the second action can get done after we wait for a specific bridge or something like that. So this opens the door for essentially more solutions from Socket, more solutions from LeFi, and essentially better UX. So what can it be useful for down the road? So the cool thing is from a dApp perspective, Ethereum will also feel like one chain. So this helps dApps scale, and as a dApp developer, one day you will not need to care that much about the underlying layer 2 that you're deploying on, and everything feels like essentially like the same thing. And as I said, it's a primitive for authorizing chained cross-chain actions. So this is really powerful. And with this, classical bridges might even become unneeded because a lot of the functionality of the bridge is handling what happens after the funds go into the destination chain. So I want to show this in practice, and I hope this works. And we have a video here, which I'm hoping that the team will play. Anyway, so I can tell you about what's going to happen in the video before we get it played. So essentially, what's going on is we have two videos, and I have a video of Stitch. Yeah. Yes, please. Okay, so since we're not getting this played, we can get Offer to show you Stitch right now, hopefully live. Amazing. Okay, so I had two demos prepared, one with Ambire Rewards, which is our own dApp, and then the second one was with Stitch, which was much more impressive. And yeah, hopefully we can get that done. Can we please get Offer connected? So anyway, you already saw a demo of Stitch recorded. So something that I also want to point out here is that clear signing is in the works because you only saw that we are signing hashes. So yeah, clear signing of the whole user operations multiple is in the works, and it's going to be like super clear to the user what's going on, which is also kind of a cool thing about the interoperability layer. So we have Stitch on the monitor, but yeah, we have Stitch here as well. So Stitch can do many things, but from the Ambire perspective, what I was going to show you is balance consolidation. So essentially using USDC from a bunch of different chains. And essentially in this case, we go to limitless and we make some bet. And yeah, so the cool thing here is that there are going to be 4 user operations in total. So the first 3 are going to consolidate balances from 3 different chains into one chain, and then the 4th is going to buy that share on limitless. And all of them you're going to authorize with only one signature. And again, all of this is happening with gas abstraction, so you don't need to care about gas fees. You only pay gas once on this. And any moment now, hopefully if the internet is good enough, we're going to get an Ambire pop-up here. The risks of a live demo. Okay, anyway, thank you everyone. Or we're gonna try again? Okay. Get kicked off the stage, we're gonna keep trying. In the meantime, do we wanna take a question maybe? Yes. I will repeat it.
Forgive me if I ask this wrong, but how does the user get the best price or swap using EIL? Like how, because if it's the way he was described before, like an intent, you don't know how you're going to get there, but you know what you want the end result to be. EIL is lower, and it should just like, you should pass the specific values, like like a token or even a function or a protocol address or like
Great
a contract
question.
can be. So how does that work? Like how does
Essentially those are solutions to 2 different problems. So you still need to solve the problem of how you're doing the swap. This is out of the scope of the EIL. The EIL is more of an execution engine, which empowers wallets to let their users have a good UX of doing multi-chain actions at once and authorizing multiple multi-chain actions at once. But the problem of how the swap gets solved is still separate. So this is why I said that they're not conflicting with the open intent framework, even though in some small use cases the EIL can replace the open intent framework. But generally speaking, those are 2 separate problem domain spaces.
Yes. The EIL is a transport layer and it's the same asset transfers. And all the protocols you've seen, like swaps, were using DEX operations. That's what Stitch does. It lets you do the swap on the source chain, destination chain. EIL does the transport.
Okay.
All right, we're out of time, but I'm checking if we can take one more question, yes or no? Okay, no, that's it. Thank you, everyone.
Thank you so much, Ivo.